Welcome back. I'm doing a bit of a different video this time around. What I'm going to be doing is I'm going to be starting a bit of a series on 3 of the systems that I have at home. What I will do is I'll break up each system into different videos, speaking specifically onto the 3 individual systems, so that we have a shorter video and you'll have a video geared towards a specific system that you may be interested in. So as I would have mentioned before, my name is Adrian Bowen and I am very much for hydroponics, to the point that I have 3 systems at this point, 3 backyard systems because I'm a backyard farmer. And of the 3, there's 2 different types of hydroponic systems. So I have 2 DFTs, or deep flow technique, or I've also heard it referred to as deep water flow, DWF. It goes by different names, but I generally call it a DFT, which is to me a hybrid between an NFT and a deep water culture system. So 2 of my systems are deep water technique systems, and the other system is a DWC, the deep water culture system. So this video will be focusing on one of the DFTs, or deep flow technique systems, which would be the A-frame system. The other system is more of I'll try and include a little video of it here. So the other one is more like what a lot of hydroponics is generally done as, which is where everything is level. So the system runs horizontally along the ground, above the ground actually. And then you have the A-frame system. Both systems generally take up, well, the A-frame takes up a little bit bigger of a space, but it just uses limited space more efficiently. So this is the system. So currently on this side, because I have a lot of scythe, I've kind of included some scythe on this side as well, at least at the start, because what happens is water is pumped up from the 2 barrels over here, so that's the reservoir. Water is pumped up to here and then into the 3-inch grow pipes, flows down and then drains out. I'll show you the other side a little later. So in this system, water comes up to this side. So at the start I decided to put the scythe in the first holes, except for this one, this is celery, but I find whenever I grow them they usually do this initially and then they turn out fine. So I have scythe, I have lettuce. This lettuce is old and needs to come out. I had some tomato seedlings that I was trying to grow. I don't really think they like this system. They have nice healthy white roots, but I really think they're not really suited for this system. I don't think they're getting enough oxygen to the roots. And I find tomatoes in particular, when you see the video on the DWC system, you will see just how expansive the roots can be. And from experience, where I downsized the air pump on one of my DWC systems, I would have had issues. So I don't think you can see it. There's a worm in there. Have to get rid of that. So you have lettuce, which they're ready to come out. These are, if I remember correctly, I think these are melon or cucumber. I think they're cucumber. I'm just putting them in here for now. They're gonna be removed. We have seasoned pepper. These will also come out. Celery. Chinese cabbage, but this is an old Chinese cabbage. I was really testing the seeds because I was having issues with the seeds in germination. They were germinating very slow. And then I have 4 kale plants. I bought some seeds and I really only managed to get 4 to germinate. And on this side, we have a lot of scythe that needs to really be cut back. It's a lot of scythe. And they've grown to the point that they really should be separated. So you have a lot of instances like this where they're falling out because of weight. But we can see just how they are. Another celery plant here. And some more lettuce. These lettuce are lettuce I brought home from work because we did not have the space. They were extras actually. So once they come out, these 3 are gonna have to be cleaned and reset. But I'm trying to get some seedlings up and ready because I'm trying to get some seedlings up and ready to put in as they come out. So why do we call it a DWF? A DFT, sorry. Why do we call it a DFT? So inside, if you look inside, if the camera will adjust, oh, actually I can just use my hand. So for this system, so if I put my finger in it, so water comes up quite a bit on my finger. Water comes up to here. So we have that much water flowing through these pipes at any given point. I don't think I can show you what the drain looks like. I might have to show you using the other system as an example. But what basically happens is we have a certain amount of water that's always in the pipes. So in the event that, let's say, current wants to come off, which, let's face it, this is until it happens. If water was to come off, the current wants to come off, and the pump stops working, there'll still be about 2 inches of water, roughly 2 inches of water. And there have been times, which it can be a good and a bad thing, because there have been times where these have been clogged. And unless I check the flow, so okay, like this one for example, could not have scripted this any better. See how it's flowing? So this is clogged. This is partially clogged. So I will have to turn this off, turn off the valve, take this out, knock it out, and put it back in. So you see how it should be flowing, right? So, because water is always in them, unless I'm going and I'm checking the flow of the water or pulling out the hoses, I may not recognize that, oh, it's clogged. As opposed to like an NFT, as soon as those plants are not getting enough water, especially in the heat of the day, they just drop lie down. So this alleviates that issue of having them drop lie down. Which is why I liked the idea of this system, because especially where I live, especially in the hurricane season, if a lamppost was to fall over, it takes a while for APA to get out here because they're going to deal with the city first and then come out. But that's what our experience has been, or what I have observed growing up. So this is side that makes the system tick. So this is the reservoir, or these are the reservoir. So It's two 55-gallon drums turned over on their side, just so that they can be at the lowest point, because if gravity is what's bringing water back, right? So the reservoir has to be the lowest point. So we had two options: either dig a hole and bury them, which up here is probably one of the most stony areas I've ever seen. To dig any hole here for these two, you would need a backhoe. That's the only way you're gonna get a hole deep enough for these. Which was not ideal, so we put them to lie down and join them. No, we never have, although it's two 55-gallon drums, we never have 110 gallons of water in here at any point, because the water level still has to be lower than this. But water can move between the two because of this 2-inch pipe we have joining them. Now this one opens, and in here we have it to be our ear stones, which I'm using two different types of ear stones. I'm using this, and I'm using, let's see if I can find the other one. This type. So when you put them in, you should see the bubbling that takes place around them. Now that is oxygenating the water, because the plant roots need oxygen. And then here's where we also mix the nutrients and add. And as it circulates throughout the system, it will dilute. So when I add nutrients to this system, what I have to do is I have to add, and then I will check back in a few minutes, or sometimes what I will do is I'll put the tester in one of the holes where one of the plants are, and I'll check the levels there, because the water has to dilute, the nutrients have to dilute with the water that's in the reservoir first, and then it's going to dilute it in the water that's in the pipes. So I'll check it there. Seems alright. I'll leave it for half an hour or so, let it mix, and then I'll come back and check it again. I'll give it take half an hour, and I'll check the pH as well. I've been trying to keep the ppm of the water here from the cistern at home. It is, the ppm generally is about 150, 175, usually around that. So when I add nutrients, I add about 800 ppm of nutrients, so end up with around 975, 950, around that, for the plants, and generally they've been doing fine. I've had issues with, as I said, so this batch I've had issues with the seedlings for the lettuce, and so came when they were 3-4 weeks old, because they couldn't fit in another system. So they were already old, we didn't expect them to come to anything, and they really didn't. But in other update videos, I'll show you what we have actually got. Now I'll include pictures of a crop that we had before. And as you see from the sieve, although sieve isn't very hard to grow in hydroponics, based on my experience, you can see that they're doing very well, doing very fine. So what are we using in terms of pumps? So I'm using a water pump, obviously, and I'm using an air pump. The water pump would be in here. Now I'm using a submersible pump. I know submersible pumps do affect the water temperature because they're using the water in the system to cool themselves. But so far, I've been fine. I haven't had any issues with water temperature. I'm using, and I include pictures of the pumps on the screen. But the pump in here is 1150 gallons per hour, if I remember correctly. And the air pump is this little air pump here, 950 gallons per hour of air. It's a very small pump, very small. Um, but it seems to be getting the job done. What I will do though, because I'm all for testing, I will get a bigger air pump, put in the system, and see if I notice any difference. I could get into the realm of hyper aeration, which I was introduced to by another hydroponic farmer here in Antigua. But I will see. Those are the two pumps combined. They draw about $33 worth of current every month, because I know that's a big thing because I teach hydroponics. Persons will ask, well, how much is it going to affect my bill by if I have a hydroponic system? So this system, it grows 130 plants, or it has 130 holes in it, and it uses about $33 worth of current every month. The amount of nutrients it uses in terms of dollars and cents is something I'm still calculating. But at the end of this, I will probably have a dedicated video, not for the sake of having another video, but I'll have a dedicated video for the cost of running these systems, and I won't individualize that video. That video will just have the cost to run the 3 systems, from current in terms of nutrients, in terms of pH up and down if I have to use pH up and down, which so far I haven't had to. In terms of chemicals, I haven't used anything on this system, but I do have BioLife and Neem, so I'm going to be implementing a regime where I'll be spraying with those are biological chemicals, or organic chemicals, so they're fine. So I don't use anything hazardous at home, because as you can see, I'm home, so I don't want to use anything hazardous here. And unless it's necessary, I wouldn't go and tell somebody to use this thing, which is highly toxic. I'll recommend, but I know I would use. So that is this system. In terms of plumbing, so from the pump, there's a rubber hose drawn to these a 1/2-inch pipe. We could have used a bigger pipe, but our thing was maintaining a good pressure for this, and not so much volume of water. So we're trying to get a good pressure, because we're pumping the water basically, I think it's 6 feet up. The footprint of this system is 6 feet in terms of width and 10 feet in terms of length, and I think it was built to be about 6 feet, 6.5 feet high, but obviously because of the slope on the ground, this side is actually a lot higher than over there. So 1/2-inch pipe goes up to this side. This may be redone at some point, but if I redo this, I will show you. Experimenting with different ways to see what is the best way. So 1/2-inch pipe basically, and then we have ball joints so that we can shut off each one individually. So if I wanted to shut off this to clean it, I can turn that valve and shut off this one individually, so it won't affect anything else. And then we have the rubber grommets and then 1/4-inch rubber pipes basically going into here. Now, why 3-inch pipes? Why 3-inch pipes? I've seen systems that have used 2-inch pipes, but the problem that I've seen is that it's very possible for the roots of plants to clog it. I had an incident where I was growing Chinese cabbage in my other DFT system, and the roots got down into the drain and actually clogged the drain, and I was only using like a 1/2-inch pipe, but I didn't expect the roots to get that far down. The roots were like 3-4 feet long and got down and managed to clog the pipe. And because I like to do a lot of experimenting, I wanted to use a big enough pipe that if I decided to go cabbage, not Chinese cabbage, but like cabbage, it wouldn't clog the pipe. And I've seen the size of roots that you can get with plants in hydroponics. So I really don't want anything to clog a pipe. So I use 3-inch pipe. 4-inch pipe, as you go up in the size of the pipe, you're going to use more and more water. Each one of these pipes holds about a half bucket of water, so that's about 2.5 gallons of water. 4-inch pipe is kind of unnecessary to me, because I'm not trying to grow like peppers or tomatoes. Those would clog this pipe. A 3-inch pipe is fine. 2-inch pipe is to me it's a little small. I mean, 2-inch versus 3-inch pipe, is it really that much of it? It's enough of a difference to me that it can affect, because I don't want anything to clog the pipes. So then water flows down the 3-inch pipes, and then we have these rubber grommets on this side. The ones on the other side, those are top hat grommets. This one now is just I think it's a 3/4 inch rubber grommet. Into this makeshift drain pipe that we put together, and then it drains back. And so this is my A-frame system.